Okay, homework 6 is on graphing reciprocal functions. So this top section, you're going to be creating your own function. So for every single one of these, know that we'll start off with f of x equals. So there are basically 3 different pieces of each one of these graphs. There is a numerator, and the numerator starts off kind of as a default of 1, and then it'll change if there's a reflection, it'll change if there's a stretch or compression. So if there's a reflection, that numerator will become negative. If there's a stretch or compression, you'll replace the 1 with whatever that factor is. So here there's no mention of a reflection or a stretch or compression, so that numerator is just going to be a 1. Next, in the denominator with the x, if there's a left or right shift, that'll be shown right there. So 2 units left, remember left is always x plus whatever the number is. And then 9 units down, that will be separate off to the side. So 9 units down means minus 9 off to the side like that. All right, and then write an equation and identify the asymptotes. Okay, so we're going to have a vertical asymptote, which is always an x equals, and we're going to have a horizontal asymptote, which is always a y equals. So we shift 2 units to the left, so that shifts from 0 down to -2, or over, I should say, to -2. And the default here is 0, but we shift everything 9 units down, so it shifts to -9. So that's that first section. We've got another section here. So write an equation that could represent the function. Keep in mind there could be reflections, there could be stretches or compressions. So this is what they mean by just could represent the function. So let's just go with the default of 1. That numerator could be anything if we keep the rest of it the same. So x equals 3, that means everything shifted to the right 3 units. The denominator would be x minus 3. Y equals -2, that means everything shifted down 2 units. So that would be your setup. All right, and then something very similar for number 6. So for the rest of these, we're doing our graphs. 7 and 8 start off a little bit basic, just having an x in the denominator. So I want to choose one that has a little bit more going on. So let's do number 10 together. So number 10, we've got a little bit of everything. We have a non-1 as our numerator, and then we have shifts in the denominator and then off to the side there. All right, so for each of these, we want to talk about vertical asymptote, horizontal asymptote. I think that's the first thing that we should mention. So this, the x plus 2, means that everything shifts to the left 2 units. So our vertical asymptote is going to be to the left 2 units as well. So that would be -2. Just remember the default for these asymptotes is 0. So if everything shifts 2 units to the left, the asymptote is going to shift 2 units to the left as well. So we can start with that. That'll be the first part of our graph. Next, the horizontal asymptote is based off this number right here. This -1 tells us our whole graph shifts 1 unit down. So instead of y equals 0, it shifts down to a -1. Okay, so we start there. That's our initial setup. And then for our actual shape of the graph, what you want to do to apply this shift of 3 is you want to plug in something just before and just after the vertical asymptote. All right, so this, like if I have a -2 right here, you want to plug in a -3 and a -1, like kind of on either side of that graph. All right, so I'm going to set up a little XY. So the middle is at a -2. So -2 is your vertical asymptote. So then you go 1 back, 1 forward, so that you can see just a little bit of what the stretch looks like. So if you sub in a -3, my denominator here will turn into a -1. So 3 over -1 is -3, -1 would be a -4. And then here if I plug in -1, -1 plus 2 is a +1. So 3 over +1 is 3, -1 would be 2. All right, so -3, -4 would be right here. And then -1, +2 would be, right there. Ignore that little one. So you can see we're going through these points. So the way that I like to graph them is just by kind of gliding down the vertical asymptote. As soon as you hit this point, then you slowly make your way over towards the horizontal asymptote. Don't keep going all the way to the center here. This is the point that tells you to curve away. And then we do the same thing this way, glide along the vertical till you hit this point, then slowly make your way over to the horizontal, and it'll look like that. Because with this number, what this stretch does is it pulls it a little bit farther away from this cross section right here. So you want to make sure you're not getting too close if you're not supposed to. All right, domain and range. This is actually my favorite domain and range of any type of graph. You just base it off of the vertical asymptote. So the dotted line tells you that you cannot hit that x value, but notice you can hit any other x value. We have arrows to the left, we have arrows to the right. So for our domain, we say any x's except the value of the vertical asymptote. And then you do the exact same thing for the range. Okay, so we say any y value except the value of the horizontal asymptote, just like that.